I came back and I was talking to one of my friends who was from Google, and I said, "Man, I went to this Ethereum conference. I don't hold ETH. I didn't contribute to the Ethereum protocol, but I feel like I'm an Ethereum guy." There is this community who's centering themselves around some core principles of permissionless innovation, principles of censorship resistance, principles of credible neutrality. And these are such overarching, powerful principles that have led to I would say, evolution of society in many ways.
Hey, welcome to the Edge podcast. I'm DeFi Dad from Fourth Revolution Capital, and I'm joined here by my co-host and colleague from 4RC, Adam, aka Nomatic. Adam, how you doing?
I'm doing great. So excited to talk to Sreeram today about EigenLayer. I'm in a analyst telegram with about 300 analysts, and many months ago, all anybody was talking about in this telegram channel was EigenLayer for about 2 weeks. So I take that as pretty good signal, and yeah, can't wait to dive in and learn more about it with the man behind EigenLayer.
As Adam just mentioned, Sreeram is the founder of EigenLayer. Sreeram is an associate professor at the University of Washington, Seattle, where he runs the UW Blockchain Labs. We are here today to talk with him about the innovations that he's building for the decentralized infrastructure of Web3. The end product of EigenLayer, if I were to try to summarize this, is a world where ETH stakers can lend the decentralized trust of Ethereum. Now, we can expect new services, apps, protocols, etc., to be built on top of EigenLayer as they eventually borrow the security and decentralized trust of Ethereum as a service. And so we're going to try very hard to make it understandable even for beginners. So let's get right into it. Sreeram, welcome to the Edge. How are you doing?
I'm doing great. Thank you so much for bringing me on the Edge podcast. Great to be here with Adam and DeFi Dad on this chat. Looking forward to it.
What originally solidified your commitment to work on Ethereum? I know we can talk a bit about your background getting into crypto, but I'm actually more interested in how you focused your attention and your efforts on Ethereum.
That's a very interesting story. I've been working on crypto for blockchains for at least 5 years, and sometime 2021, I think June, I decided to take a break from the university and try to build a project. And initially we had this goal that, hey, how do we enable anybody to more easily take new ideas at the infrastructure layer and come and, build on top of a common existing platform? And we hadn't converged on Ethereum as the place to build. Of course, from the outside, I had interacted a lot with researchers from, in the blockchain space, both academic and in the in the practice domain, for example, EF researchers and so on. But we hadn't decided which platform to build on, and more importantly, I didn't have any exposure to the communities, the rich living communities behind these blockchains. I just viewed them as, hey, A has this consensus protocol, B has this thing, and it's all just like a technical analysis. And I would say the pivotal moment was last year when I went to ETH Denver. And, so this is last year around this time, February, March, I'd gone to ETH Denver. It's probably the first time I went to a practical crypto conference. I've been to a lot of academic ones. And, I could sense the spirit of the community in the whole Ethereum ecosystem. And I came back and I was talking to one of my friends who was from Google, and I said, "Man, I went to this Ethereum conference. I don't hold ETH. I didn't contribute to the Ethereum protocol, but I feel like I'm an Ethereum guy." And it's such because there is this community who's centering themselves around some core principles of permissionless innovation, principles of censorship resistance, principles of credible neutrality. And these are such overarching, powerful principles that have led to kind of, I would say, evolution of society in many ways. Just taking some of those things as the pivotal principles and building a community around it. And anybody new or, coming in, once they align with the principles, they can feel a part of this community. And I asked my friend, like, how many times have you had somebody go to a Google conference and come back and say, I'm a Google guy, like having not working there, not, really even using their products in any way, but just feeling like, okay, this is the vibe that I want to kind of like associate with. So that was really a fascinating moment for me when I'm like, okay, that's what we're doing. We're building on Ethereum.
I love that answer, because if I were to summarize very concisely, it was vibes. So that's awesome. And kind of before we jump into EigenLayer, I'm just curious, just as your time as a professor at a university, how are students being introduced to crypto, blockchain, Ethereum, etc.? Like, is there, like, what is the teaching looking like right now?
Okay, that's a really interesting question. I think mostly universities are not the ones introducing the students to crypto. Students have already kind of familiarity. Maybe they bought an NFT. Maybe they were trying to have day trading on the side. Like, they were doing something and they got interested. So most of the time, that's their portal. I would say more than kind of courses that people like, me run as academics, it is student societies where they get introduced, like they go hang out, get a pizza, grab a beer, whatever, and then talk about like crypto. I think that's where almost all of the students like get introduced. The course I was running at that time was a graduate course. It's for students who want to design new protocols. So it's basically taking like, distributed systems like PhD students, information theory PhD students and so on, and trying to tell them like, hey, there's this really cool area, you should really figure out how to kind of contribute to it. But I think what I realized, and, it wasn't clear to me at the time when I was mainly an academic, what I didn't realize is the amount of like, latent energy from the student community that has been unlocked by crypto, and primarily because of the ability of crypto to enable the outsider to like come and contribute. And the reason I think this is true is that you have this amazing underlying principle that, underpins Ethereum and in general any of these like decentralized platforms, the idea that you don't need to be trusted in order to build applications. You're borrowing trust from this massive source of trust rather than you yourself having to be trusted. What this has done is unlocked like a wave of, you don't have to be anybody in particular. You can be a nobody and build on top of this platform. And that's just so amazing. And I look at it, I also used to work on AI, right? Like that's the other like big thing going on. And you look at these two areas, AI very, very clearly and strongly favors incumbents. Like it's extraordinarily difficult for somebody from the outside to like say, hey, come in and contribute and improvise and like contribute to the state of knowledge. I think it's not the technical barriers. It's not like crypto is any easier. AI is more difficult. I would even say in some sense, AI is a little bit easier because, you can play with it and do a lot of stuff. Nobody has access to the same kinds of data, to the same kinds of compute and so on. So there's a lot of barriers in anybody entering into the space. Even academics struggle, like with multi-million-dollar grants. You can't compete with multi-billion-dollar companies. So it's just like a huge gap there. But I found it's exactly the opposite in crypto, that basically because it empowers anybody to come and build, there is this amazing bottom-up culture, like, kids coming up with crazy ideas, throwing it out there and seeing what's happening. I was just so fascinated when I discovered this. And it's partly one of the missions of a university is to empower something like that. And, I was like, oh my God, I was at a university. I was running a blockchain research lab with basically PhDs and stuff. And I hadn't quite understood the amount of latent energy that this has unlocked. Took me many years to actually kind of get exposed to and understand that subculture. I'm very thankful that I got to do it. And right now, we have people engaging in our startup and in the lab and other places where it's all, through the spectrum, including like people just getting out of high school to, PhDs and postdocs. So.
Yeah, I think what you just captured there is crypto unlocks accelerated social mobility. It's like one of the few places that reinforces that any person can come build, invest, contribute in all sorts of other ways. And that is something I want to say that that's an idea that, keeps people really inspired and excited to work hard on hard problems and to create new value, to work on things that are a positive sum, not something where, we have to ultimately live in a PvP world and the type of world that I think Wall Street reflects. And no doubt that is the impression that all of us got. And I think it's part of the reason we're all here. We feel like we're in a sector that's just unlocked all this new value and so much more value that hasn't been unleashed.
Totally. So there is this saying that I think, I don't know who came up with, maybe it's Chris Dixon, that Google said don't be evil and crypto can't be evil. I have a variant of it. It says, people are saying don't discriminate. Crypto can't discriminate. And that's a superpower, right? I can't discriminate whether somebody is working from the US or from some other country or whatever. They're a student. How are you going to know? You can't discriminate. I don't need to, because they don't need to be trusted because somebody else is underwriting trust for them. This idea that the decoupling of innovation and trust, who brings innovation, who brings trust, what it unlocks, I think we're at very, very early stage. And, you just mentioned this thing about non-zero-sum games. It's a kind of like one of my root philosophies is non-zero-sum games. And if you think about what makes non-zero-sum games possible, right? For the listeners, non-zero-sum game is when two people are playing a game and both of them have a win in it. It's you can think of it as win-win games rather than win-lose games. And what enables humans to have to build non-zero-sum games? And I think there are really two major pillars that enable non-zero-sum games. One pillar is cooperation, right? The three of us here, we could kind of go our own way and do our own shows or something, and it wouldn't be as interesting as the three of us coming together and presenting this thing where there's an interchange of ideas and stuff. So cooperation creates more value than the sum of the parts, right? So this is a non-zero-sum aspect. And there is another non-zero-sum game, and that is innovation, right? Because of innovation, we can take sand and turn it into silicon and crazy products. We can turn some atoms in the air into energy and through fission and fusion. Innovation unlocks the internal potential, which simply wasn't available. So that makes non-zero-sum games. These are the two non-zero-sum games. And I think crypto, my own thesis for crypto is it unlocks both of these in a massive way. It unleashes the ability to cooperate because we can work with each other when there is a kind of common element of trust, or we don't have to necessarily rely on each other to know each other, to trust each other. So that's on the cooperation side. On the innovation side, the idea that I can innovate and compose with other people's innovations means everybody can contribute incremental units of value that then turbocharge each other without having to say that, hey, I have to come up with my own end-to-end platform and end-to-end output. Instead, we all build small units that work together to actually make something much bigger. These are the two values I think these are the two bases of non-zero-sum games. I think both of which crypto turbocharges. So I'm very, very excited to be part of this community.
I think we have now a clear picture of the principles that drive you as a founder, as a community member of Ethereum. So what are the assumptions that we have to consider to understand the solution that is EigenLayer? What is the status quo in a world where EigenLayer does not exist?
Yeah. So, I alluded to this concept that what really Ethereum did, I think other blockchain platforms followed after this, is the idea of decoupling innovation and trust. The idea that I have this common decentralized trust platform. Anybody who's writing a smart contract application, they can write it and throw it on top of this common platform. And when somebody's using it, they don't need to know the antecedents of who is this person, who wrote this code, are they good or bad? Are they going to continue to provide service? None of this matters, because if that code is correct and you trust the Ethereum, the platform, then that's it. That's all you need to know. So this creates this separation of who brings innovation and who brings trust. The Ethereum blockchain brings trust. The person who writes the contracts brings the innovation, and they both meet and fuse and create this new applications. And I have this example, which I think is useful to think about, is the scale of what decoupling of innovation and trust is I think very similar to the scale of what venture capital did. It's the decoupling of innovation and capital. Venture capital, it's not that old, right? Maybe 60 years, 70 years, that's the time scale at which it has kind of flourished massively. And the idea that I can bring innovation and you bring capital, and these two work together to create an output. Otherwise, you need to have a double coincidence. The person who's innovative needs to have the capital, or the person who has capital needs to be innovative. When, if the probability that somebody has capital is 1% and the probability that somebody has innovation is 1%, it becomes 1% times 1%, which is 1 in a, 10,000. So this is the same problem with the coupling of innovation and trust, which is what I would say Wall Street was. And we just alluded to that a little bit earlier is, I'm JP Morgan, I'm trusted, but I also need to come up with what innovations need to be built. And this is not only we should not just think of it as, these guys were all in it together or whatever. The structures that were needed, that the fact is that the person, when they are offering a financial product or an instrument or something, they need to be trusted. How are you going to trust them? You're going to trust them because they are legally regulated. You're going to trust them because they have a 150-year reputation. Otherwise, why would you trust somebody to handle these kind of complicated things? So the coupling of innovation and trust massively reduced the surface area of innovation. And what blockchain does is separate these two. The decoupling of innovation and trust, the ability to take trust off and put it in a common platform and then let anybody innovate on top. So this was the status quo, and this just blew my mind once I understood the scale of what this can be. The idea that anybody can do this was amazing. But this still contradicted with my own experience working on blockchain. What is my experience is, hey, we built, in the University of Washington Blockchain Research Lab, and I was seeing a lot of other very innovative people in the university and research labs and other places building very cool new protocols. How do you build a very efficient consensus protocol? How do you build an efficient data dissemination protocol? How do you build a scalability layer? How do you build a, game theoretically optimal oracle? Whatever the set of things that people are coming up with, there was no place for them to just say that, hey, I'm just taking my idea and throwing it on top of an existing trust network. In fact, the barrier for somebody with a core infrastructure idea to create it was to basically go build a new trust network. Okay, you yourself being trusted is one thing. You are able and capable enough to build a decentralized trust network is just so wacko. How many people have the ability to lead social movements, right? That's just, it's insane. And the idea that the person who would have the best consensus protocol would also be the best leader of a social movement is, it's insane. Maybe there is one Vitalik or something, one more person like that out there, but there are not many of them. So it's not a normal thing. It is not a easy thing. So it's massively reduced the rate of innovation at the infrastructure layer. So anything that could be built as an EVM smart contract, yeah, that's awesome. People built it. And anything that was deeper, there was a friction. And I think the one way we can view this story is, Ethereum basically came and opened up. So before Ethereum, right, if you look at Bitcoin, if you wanted to build a new application, you could not build it on Bitcoin. You had to create a new type of a Bitcoin, right? Like there was this name coin, which was a domain name system at that time and so on. Just any one specific application needs to be like a whole new, oh, I have this mining protocol, I have this whatever staking protocol, something just for that particular use case. And this was the status quo, and Ethereum broke it by like opening it up. And I would say that was like the first major opening of permissionless innovation. I would say the second one was the layer 2 era. The idea that you could, and you know, this is again a place where you can see what happens when you move from like a constrained innovation space to a competitive permissionless innovation space. And Ethereum was initially going on this roadmap, like after Ethereum, everybody else like also said they're going on this roadmap of sharding. Like how do you like fragment the state that is run on Ethereum and, you know, split it into many, many parallel execution environments. And Ethereum was going on this roadmap. It was very difficult for like to converge on what is the right sharding architecture, because maybe there are 30, like, and we have to discuss a debate and only one of them can get in. And when you start building on it, it is a 5-year roadmap. Ethereum is a massive ship. You can't make sudden jerks and movements and scare people away, like, or drown them. Like, it's not acceptable. And so there was this whole roadmap which was centered around sharding. And, you know, Ethereum basically did the unthinkable like 2.5 years or so back by saying that, yeah, it's fine, we don't have to do sharding. We let the free market do sharding, the layer 2 protocols. This was crazy. Like at that time, like nobody would have anticipated that this is going to be something crazy and big. But what this did is make things like Rollup first-class citizens. You know, hey, we're not competing against native sharding, right? Like that would have been ugly. Oh, there's native sharding, but also there's rollups, and we have to fight with each. Like this is almost like, I think this goes back to an earlier story, which is Ethereum not deciding to build things like DEXs as native parts of the protocol. I think this is less appreciated, and we think of it as like, of course, that should be the case, but it's not at all obvious that that was the right thing to do at that time. And it would have been, I was not paying attention, I was not in crypto at that time, so I don't know the stories. Maybe you guys do. I would love to hear them. But the idea that Ethereum remains completely credibly neutral and lets other people build and compete on things like taxes and stuff is amazing. This credible neutrality is what has led to this like massive growth of permissionless innovation. It's the same thing with, I would say that was the first phase is like at the level of dApps. The next phase is at the level of rollups. But rollups, while they can do one particular thing, they're offloading and scaling execution, you cannot use them to change the consensus protocol of Ethereum or add on a new consensus protocol or write a new bridge or like do a new oracle or any of these other like infrastructure components that are equally needed to run like a very powerful ecosystem. So what we think of as EigenLayer is just opening up this permissionless innovation space even more. And what we're doing is saying anything that you can build on top of a new trust network, you can borrow, I think, as we saw in the short introduction, the idea of EigenLayer is enable the Ethereum staking, decentralized trust arising from Ethereum staking to be supplied to any application, to any protocol, to any, it could be a chain, it could be a service, it could be a module, it could be an application, anything that requires a decentralized trust network, to then like just rely on this existing massive trust network. Again, now enabling anybody who wants to innovate to say, hey, I don't need to worry about where decentralized trust comes from for my particular application. I've already given it to the Ethereum network. Ethereum stakers who opted into the EigenLayer protocol, they can now service this other application. So EigenLayer, to be clear, is not a new chain or a new protocol. It's a new protocol on top of Ethereum. The way it works is it's a series of smart contracts on Ethereum. That's all that it is. And this set of smart contracts allows the existing stakers to communicate their intent to participate in new protocols. And the EigenLayer core protocols then talk to these like service protocols, which could be, oh, I'm running a bridge or something else. And you, as a staker, you're now opting into this new protocol. And what it means is you're accepting to the registration conditions, to the payment conditions, and to the slashing conditions. So that's roughly high level. What we're trying to do is continue on the same trend that Ethereum pioneered with the launch of dApps, with the launch of layer 2 rollups, just taking it even further and saying that anything you can think of as building on a decentralized network can now be built on EigenLayer.
I love that background because you kind of see, just your time at the blockchain lab, students and people just continuously building new blockchains and having to create that trust network. And that's not easy to do. And then we've got Ethereum sitting over here, which has this robust and kind of proven trust network. And you can kind of connect the dots to how you arrived at the conclusion of just like, hey, why don't we just use Ethereum, guys? And then let's just see what happens. Because I think, personally, I think we're going to see just a mass proliferation of creativity that's now been unleashed due to that like bottleneck before of, okay, hey, I've got a great idea, but first, okay, I got to create this robust trust network on my own and, go through all those steps and build in that security. So yeah, it's just really cool to kind of see how you progress to this idea with EigenLayer. And I think you've kind of like now answered what is EigenLayer. And would you say it's almost fair to say it's Ethereum's security as a service, or do you have like an even more simpler way of kind of defining it, or is that correct in your opinion?
I think that's a great way of putting it. You can say it's Ethereum security as a service. Another way of saying it is it's a marketplace of decentralized trust. So if you look at what is like a crypto application, I think we would all agree that the essential ingredient of being a crypto application is that there is some decentralized trust underpinning it, right? That is the core. If you just remove that, then you'd say why might as well run it on AWS and you're done, right? So if decentralized trust is the core ingredient, like the oil powering like this entire industry, where are the marketplaces for pricing and evaluating the different dimensions of decentralized trust? If we don't have it, it will be underproduced. That's what we know from like all other kinds of examples, is when you don't value it and pay for it, you're not going to be able to produce an abundance of it. And that's really what EigenLayer is aiming to be, is a marketplace for decentralized trust, where decentralized trust, which is emerging out of this Ethereum, is being sold. That's why it's Ethereum security as a service. But when it's being sold, people can price like the different dimensions of decentralized trust. So like one way of thinking about it is what are the aspects of decentralized trust in Ethereum? And I would say at least there are two distinct aspects. One is the idea that there is some amount of stake, some economics backing like your claims. And in the Ethereum protocol, you're putting down a bunch of stake, which is ETH, and saying that, hey, I'm going to run this Ethereum node. And if I kind of deviate from some of the core conditions of the Ethereum protocol, I'm willing to lose my ETH, right? So there is some economics powering and backing my commitment to run this Ethereum protocol. That's one kind of aspect of decentralized trust, which I would say is economic trust, right? And the thing about economic trust is it doesn't matter if one whale puts up 20 billion or like millions of people put $2,000 each. It's still 20 billion. So, right. So the idea is that economic trust is invariant to who is contributing the economics, because you know that if they fail, whether it be a single whale or millions of people, if they fail, then basically you can slash and take away the funds. So that is one kind of trust. There is another kind of trust also emergent and very important, which is right now not being metered. The trust is that which is arising out of decentralization. What do I mean by that? Is, are these you could say there are 1,000 nodes running. Are these nodes really decentralized? Are they around the world? Are they being run by the same person? Or is some person paying all these 1,000 nodes to do it? Actually measuring and valuing decentralization. This is one thing we know from being in the Ethereum community, that there are thousands of home volunteers around the world who are just like running it. Of course, they're making money, so they're not purely volunteers, but they're contributing to the social movement while also making an economic gain. So that's what is going on with Ethereum staking. And the thing is, I'm sure in this show you discuss a lot about things like MEV. And when we think about things like MEV, one of the important things we think about is, does it have a centralizing tendency? Like, is there any way in which like, we don't need to be decentralized. We just run like one validator, and that's actually more profitable than maybe everybody will start running one validator. But so the thing is, in existing protocols, there is a natural drift to centralization, because if you centralize, you can kind of like, you have more economies of scale, you have more efficiency, but there is no drift to decentralization. But that's bizarre. Like, our whole space is predicated on the idea that there should be decentralized trust. And there is no way to value and pay for decentralization. What is this? So, of course, it's going to get under-provisioned over time. This is one of the things I'm most excited for about EigenLayer, is it has a way to value and pay for decentralized trust. Imagine a service building on top of EigenLayer. And before I go into this, I just want to clarify the two trust models. The true trust models are, you would rely on economic trust when the type of errors that you can commit are provable and slashable, right? Like, you produced an invalid block. That's a solid like error, and it's provable on chain. I can prove to you that, hey, he produced an invalid block. You should never produce an invalid block if you run the proper client. He did it, so I'm going to take away the funds. So this is a solid like attributable error. There are many non-attributable errors. I don't include somebody's transaction. Okay. And why do I not include it? Maybe because it bids up, there's a major auction going on, and, there are like $10,000 bids and $2 million bids. And if I censor these $2 million bids, then I can buy the object for $1,000, right? So there's a huge amount of reliance of censorship resistance, not only in a kind of geographic manner, but also in every manner in the protocol. If the oracles get censored, if the bids get censored, like, this system's not going to be functional. So we need a massive amount of censorship resistance to actually have a functioning protocol. And how do we get it? We get it because, and it's not attributable, right? Like, how can I prove to you that you got this transaction and not included it? It's not a provable fact. It's not attributable. And the only solution we know of as like blockchain architects is the idea that, have a decentralized community bear testimony to this, right? Like, you have 1,000 nodes, and if a majority of the nodes say that they saw the transaction, then that transaction is included, and so on. So you can have, if we have a decentralized group of nodes, then that's one of the protections against like non-attributable faults, because as long as you can extract a majority opinion, then it's very valuable. And so on EigenLayer, like, people building services, EigenLayer is a two-sided market. If it's a security as a service, then basically somebody's providing security, somebody's buying security. Decentralized trust marketplace, same thing. You're supplying decentralized trust, somebody's buying decentralized trust, right? And so services which are built on EigenLayer are the ones kind of buying this trust or renting it, right? Because it's temporal, like you're paying per unit time, and if you don't want it, you can move away. So you can think of it as renting trust. But the idea is that whoever is buying this trust can say that I actually want to rely on decentralization. I only want to admit decentralized nodes into my protocol, and it could start valuing decentralization. So what could happen is, if a lot of services are built on EigenLayer that pay a premium for decentralized nodes, then decentralized nodes start earning a premium relative to like centralized nodes, and there is a drift to decentralization. This is insane. This is amazing, because now, it's a core commodity that we value, but it's a public good that nobody wants to pay for. Then it's just going to degenerate. But if it is something that is valued and paid for, then people will produce it more. Somebody say, oh man, there's like 1% premium if I run a node from Rwanda, and like, just do it, right? And that's awesome.
Yeah, I think like my aha moment when I was kind of looking into EigenLayer, it was a quote that you said that I heard on a podcast, and it's essentially like, I'm kind of sick of the meme that, nobody cares about decentralization. When it's like pivotal to the entire ecosystem. And what I love about EigenLayer is like you've been saying, you're finally introducing a value to decentralization for like, as far as I'm concerned, the first time I've ever seen that. And that's so novel to me because, now there's going to be an incentive attached to being decentralized. It's not, it's I think it's just going to unlock so much potential, and I'm super stoked. But anyways, I'll let DeFi Dad jump in here.
Do you think a good parallel is if we think about Ethereum as like a city or like a digital nation state, and then we've got other applications, protocols, even blockchains, the nation state of Ethereum, its number one export then becomes this decentralized trust or security. So we're basically allowing stakers ultimately to ship that trust out, and that is then being imported by these other blockchain cities, nation states, and so on, which is why it's so radical. Like, it's not a parallel. I'm sorry, there's no parallel, there's no comparison other than really what I just said that has helped me to better understand this. But yeah, am I making sense?
Yeah, this is really, really kind of one of our pivotal mental models here. And I think you kind of articulated it very nicely. The idea that, okay, so before we go to the nation state model, let's start with what Ethereum itself did. Ethereum basically said, city states are no good, let's build a nation state. What is a city state? A dApp chain is a city state, right? Bitcoin, is of course a massive dApp chain. So it's exceptional, so it can sustain its own economy. It's great, let it live, right? But every new tiny application cannot create its own security. It's just like insane for like tiny cities or new cities to spring up if you say that each city needs to have its own like armed guards. And what Ethereum did is it said, hey, we're drawing these borders and anybody can come and create new cities here. City is an application, right? Like you can create all these new cities here. And we now we provide integrated security to all of these cities. Now, like a lot of people coming and constructing cities saying, hey, in my city, you could come and do this and so on. It's an amusement park, whatever, all these things being constructed. So Ethereum itself is the shift from city states to nation states. So city is the application, nation is like, okay, now there is an issue with the nation state model of Ethereum as of today. What is that? So if you're running a DeFi application, you are relying on the Ethereum security to secure block production, censorship resistance, and all of this stuff. But it does not secure your oracles. It does not secure your bridges. It does not secure some of the other functionality I need to be as a city. So imagine if this is this nation state and the dApps are these cities, suddenly as dApps become richer and richer, they have this new surface of exposure. Maybe there's an air attack, right? Like the air is, let's say, the oracle, right? Like there's something's coming in and, you have like armed guards just standing guard on all your four borders, but nobody's protecting the airspace. And so somebody says, oh, hey, I'm an oracle service. I'm providing defense against air stuff. And have this new security model on the third dimension, which is, oracles. You have some other security model in the fourth dimension, which is bridges. You have different security model in the new dimension, which is data availability. And now, as a city, you are less sure how much of security am I really getting from Ethereum, because you have this massive armed guards standing on all the borders, but then you are at the end of the day constrained by the worst security exposure, right? Like could be the oracles exposed, then it doesn't matter that you're in a very, very secure block production. If the oracle's gone, your tap collapses. So this is the first thing that I think EigenLayer can redeem, is by making the security of Ethereum programmable. Now this can supply the oracle, this can supply the data availability. The same security can provide all these different services. By provisioning more and more services, what happens is you're collecting more and more fees. The Ethereum security is collecting more and more fees from these different services, and this grows its security for everything uniform, right? Instead of having, let's say, 20, 25 billion stake, which is the case today, maybe we will have 50 billion state, because we're not only securing block production, but we're securing oracles, we're securing bridges, we're securing all these different things together. So that's the first element on this analogy that I want to emphasize is city-states and dApps, nation-state, Ethereum, but then you have this new thing of things like air exposure and space exposure and border exposure and different attack vectors, and there were different local defense systems built for each of these things. And so no, that doesn't make sense. You need to have an integrated response to all these different kinds of security attacks, and that essentially grows our own volume. This is before Ethereum. So now I'll come to the next level of what EigenLayer enables. This is already something that's uniquely enabled by EigenLayer, because EigenLayer enables the Ethereum security to be programmable and supply it to all these different services, to be the air guard, to be the navy, to be the protection against chemical weapons, whatever. Right? So you have these different dimensions of attacks. You have a uniform security protection against it. That's number one. Number two, building on this analogy, which I think DeFi Dad beautifully laid out, the idea that you're not only supplying security to your own nation, you're exporting security to other nations. Somebody says, I could be like a dApp on Ethereum and consume additional modular services built on Ethereum. That would be the first class. But what I could do is, I could just be my own chain, my own nation, but I'm borrowing some aspect of security from Ethereum. That's the security export analogy. I think it's a great analogy, and it will happen that basically when a nation state starts, a new nation state starts, they'll say, yeah, okay, I'm borrowing security from Ethereum, and I'm going to build this up a little bit. And as I build this up, I'm going to be borrowing it. And, if I have enough security on my own, then I may say I don't want to borrow it anymore. It's totally fine. It's a free world. We want as much of innovation surface to happen. So things like that will happen. But because Ethereum's going to have itself be much more tightly integrated in its own security because of EigenLayer, you have all these other services built, and they're all permissionlessly innovated on. So it's not like one oracle that one group of people have to come up with. It's not one scaling solution that one group of people come up with. It's a permissionless free competition. There's somebody out there who will make a 10,000x in figuring that out, right? How to build the best oracle, how to build the best data scaling, how to build the best each one of these services, and they're all going to come in and do it. And so that's the power of EigenLayer, what it does to the Ethereum ecosystem, but also what it supplies to other new people starting just completely new chains which want to be on their own turf. But initially they have a bootstrapping problem. They want to just borrow something from Ethereum.
With over 170 million TVL cross-chain, the multi-chain liquid staking protocol Stader Labs is just about to launch the ETH liquid staking token ETHX. ETHX will give you the best of decentralized staking and DeFi yields. What's more is that anyone can permissionlessly run an ETHX node with just a 4 ETH bond. To get more alpha on the ETHX launch, go to staderlabs.com/Ethereum. With all of that understood, then, how would you envision a future UI UX in terms of using EigenLayer? What are some of the applications, I guess, that we would expect, once EigenLayer actually goes live? I'm thinking about this kind of as a lending borrowing market where ETH stakers are lending, providing the, security or trust of the Ethereum network. And then you've got builders, apps, and so on, either buying or renting that trust. But yeah, do you have any sort of vision at all for what some of these interfaces might look like?
Yeah, we're very early in this design. Would love to solicit inputs from the community, but I can provide a high level understanding of what the set of possible interfaces are. The first one is, there are two sides to the market, right? One is stakers and the other is service builders. Even stakers, you can kind of divide into two groups, stakers who have the money, and then node operators who might be the same as stakers or might be different from stakers. This is staking as a service providers or whatever. Let's call them node operators. So you have stakers who have the money, you have node operators, and then you have service builders. So what are the different interfaces? I'll start with the service builders. service builders, what are they doing? They're writing a new service. What does it mean to write a new service? You write like node software for that service, which is downloaded and run by node operators, right? Node operators need to be running all these services, and they'll download and run these services. And the service builder is building this off-chain component of the service, but it's also building an on-chain component, which is the smart contracts that adjudicate who can register for the service, who can, what is the payment condition? Maybe I'm paying like 1 ETH per gigabyte of data stored, whatever, some equations like that. And then the third one is if they misbehave, for example, they don't store the data and I recall the data on chain and they don't produce it, I'll slash that. So there is some set of conditions that is built on the Ethereum contracts. So that is the protocol for a service has an on-chain aspect, which is writing a service smart contract in EVM, which talks to the EigenLayer smart contracts. Off-chain, you're building this like software that node operators have to download and run. So that's the UI on the service side. So what set of conditions are needed for the off-chain software and stuff? We're just on the process of designing. But the on-chain like interfaces we've already designed and we'll hopefully make it public in the coming 2 months. So that's the service side. Let's look at the staker side, which is the monetary aspect or the economic aspect of this. Who's putting in the money? So you may go to a web interface and say, hey, I have this this much of ETH, or I have a liquid staking derivative, or I want to natively stake. Whatever the thing is, I would say that and then say that I'm putting in this much of money and I want to opt into these 5 protocols, or maybe there are risk levels and you say like I want to only opt into the lowest risk, medium risk, according to somebody you trust. You just go with some list of recommendations and you go in and you say, yeah, I'm opting in for all these services and here is my node operator. It could be yourself because you have a home node and you just want to run more services on it. Or it could be like, hey, I'm going to delegate it to some third party like Coinbase Cloud or Chorus or Figment or something. And so you do that, and that's basically the stakers interface, right? So they're basically saying how much stake they're committing. They are also saying who is it that is providing the node operation. Node operators, their interface is simple. They're downloading and running these services in exchange for some free market rate of a fraction of fees. I think one thing I want to point out here is if you look at kind of the ecosystem today, the cost of running the nodes, the operational cost of running and maintaining nodes is actually not that significant. Even in extreme scenarios like, Solana, people say it consumes a lot of computational power, but even there, running a node like annually is $10,000. And like maybe there are thousands of nodes, like that's like $10 million annually. But the cost of capital of staking Solana is like maybe $500 million, right? So because you're staking like 5 billion or 10 billion worth of Sol, and that basically means like if you want to give like a 5 to 10% APR, we're talking about $500 million to 1 billion. So the cost of staking is fundamentally the economic cost, and the node operating cost is very small. What you can think of EigenLayer as is a way of amortizing capital cost across node operation costs. So instead of just doing one like specific node operation, you run like many, many different nodes and you amortize the cost much more equally. So that's the UI UX on the 3 sides of the market.
While we're kind of on that topic of node operators, something that's kind of like top of mind for me is the liquid staking derivatives and how they've found product market fit in a post-merge world, and would love to hear you kind of speak to how EigenLayer aligns or integrates with some of these liquid staking derivatives providers. And if you could also touch on like, are there any that are like more preferential because of like broader decentralization, or is EigenLayer kind of able to integrate with all of these LSD providers?
Yes. So there are 2 ways of restaking on EigenLayer. One way is you can take a liquid staking derivative and deposit it into the EigenLayer contracts, and that is a way, and then you can appoint who your node operator is. That is one way of restaking, which is liquid restaking. You take a liquid staking derivative and then you can restake on EigenLayer. You can also do native restaking, which is you're a home validator. You don't want to go into any liquid staking protocol. You just set the withdrawal credentials to the EigenLayer contracts, and then that is counted as native restaking. And the way that works is if you went nice and did all in the normal path, you would be able to just withdraw your money from the EigenLayer contracts. But if you did something bad on some EigenLayer service, when you try to withdraw your money, EigenLayer contracts will hold off a portion of the money and then only let you revert the remaining ones. So these are the two types of restaking. One is liquid restaking and the other is native restaking. Now, to answer your question as to which liquid staking derivatives do we support or want to support, we want to support everything. One of our core design principles on EigenLayer is what we call intersubjectivity. Intersubjectivity is a principle of neutrality. The idea is we don't make subjective decisions to the extent possible. Let each service, so let's say you are building an Oracle service, and then you say, oh, I only want the most decentralized quorum. I only want native restakers. Yeah, EigenLayer will allow you to only get security from those ones. You say, no, I'm okay with only native restakers and Rocket Pool. Whatever. You say, yeah, okay, you can opt into that. Somebody might say, actually, I don't really care about decentralization. I want the maximum amount of economic security. Why? Because if they misbehave, I have a way to keep them accountable. I can slash them and I don't care. And they may say, yeah, Coinbase ETH is enough, right? So it's a spectrum and everybody can come and decide. So it's a completely neutral platform in that sense that anybody can come and decide what each service exerts subjectivity onto what set of either liquid staking or native staking services they want to support. And the way we think about the relative value of more centralized versus the most decentralized, and I would say something like Lido is in the middle and they're trying to get to more decentralized by building this new permissionless liquid staking protocol. The idea is that it's not for us. We want to be as close as possible to just Ethereum staking. Take a completely unopinionated position on, how these things play out because, things can start out in one way and turn in another way. It could also be that there is a bifurcation and people say, oh, there is a lot of applications for which I don't really care about decentralization at all, and one node running it is good enough. And maybe and because it's only one node running it, there's a huge amount of operational efficiency, which is I don't have to pay a lot for operations, and the heavier services maybe just gravitate towards that. And there may be other services which absolutely need and want decentralization, and they will say that I'm paying whatever premium is needed to get decentralization. I'll pay more and these nodes. So the market will then evaluate the relative merits of all these things, and I'm as good a judge as any of you as to how that would play out, but at least there is no preconceived conclusion that the centralized one node thing is the best. That's not the case. There is some value to decentralization. There'll be services which differentiate themselves on this merit and say that here is a service that's built on the most decentralized network, and if there is a use, and I'm sure there is a use for decentralization. If there is a use, people will pay for it, and that fee will go to the decentralized takers.
Yeah, that's so cool. EigenLayer essentially indemnifies themselves from having to make that decision and just leaves it up to the market, who will make whatever decision that they want based on kind of that risk reward calculus that will eventually play out. So that'll be really interesting just to see that kind of human behavior aspect of that. One thing I want to kind of key in on too, EigenLayer will essentially be taking control of staked ETH at some point. And I guess we're talking about trust, and you're gonna be dialing into Ethereum's trust. How does EigenLayer build the trust initially to allow people to be comfortable with that? And what's your plan there?
Yeah, it's a question we think about a lot. When we want to, I think there are two parts to this. How do we make sure our system is solid and airtight to make sure that we are as the contracts take in people assets, how do we make sure they're safe? We're thinking about a lot of things like how do we add circuit breakers, how do we add pass functionalities, how do we protect ourselves against contract bugs. I'll dial into that, but before that, I want to make like this high-level observation that one of the basic propositions of blockchains is creating non-subjective mechanisms of trust, right? But at the end of the day, all of trust is, you could think of blockchains as either, you can take two extreme views. One view is blockchains are, creating objective trust, in some way. Another view is blockchains are just codifying subjective trust. They're just like making it easy for people to take the subjective trust, which is essentially emergent from the community. And then, but a community cannot meet every 12 seconds and agree on stuff. So we're just like making an algorithm that then like executes our will, but it's at the human level. But this interplay between human subjectivity and like purely objective mechanisms is, I think, a very fascinating one. And we are not taking an extreme position on this, saying that, for example, it has to be all objective trust or it has to be subjective trust. And we have to interlace these two in like complex ways to get these systems to work. And you can already see it in things like DeFi protocols or things like rollups, right? There is a governance layer usually attached to it. And the governance layer can, step in during, if there's a contract bug or if there is some set of like issues, there is a subjective layer that can activate itself and like help people work through it. Because we are far from a scenario right now in blockchains where we could say, oh yeah, contracts are all formally verified and like, it's exactly does what it says and you don't need to worry about it. I think we are not there. So we are putting a series of precautions in place. One is basically having a layer of human subjectivity and like emergency upgrade procedures, which could be basically Ethereum community members essentially having the ability to trigger upgrades if there are smart contract bugs. There is the general class of how do you govern a protocol which has staking, right? And I think this is similar to all the DeFi protocols and all the layer 2s. There is another thing which is specific to EigenLayer. And the thing that's specific is, what if somebody writes a contract or a service on EigenLayer which promises somewhat of a higher yield, everybody opts in, and once you have everybody opted in, it just slashes all the stakers, right? Like this would be the nightmare scenario. And the way we prevent against it is by having a veto for slashing. Like there's a kind of Ethereum community members who only thing they can do is to veto slashing decisions before they are actually actuated. So you don't slash before like the veto time passes. And so this enables a layer of human subjectivity to come in and say that, yes, okay, this is actually a valid slashing decision versus it's not. And so slashing on EigenLayer is designed to be naturally wrapped. So you don't, trigger slashing on a regular basis.
Can you go back to then this issue of slashing? What happens when you're a staker and let's say you're lending security or trust through EigenLayer and you get slashed? How does that affect those on the other side of the EigenLayer market who are borrowing that trust and security?
Yeah. So if you're a restaker and you get slashed, let's take the simple example of your depositing liquid staking derivatives, right? Which is, okay, you have some people who have staked on one service and, they've basically misbehaved on that service and then they lose their stake. And if they lose their stake, now, they're no longer, because all of this can be kind of instantly understood by the contracts, at least as soon as somebody has triggered the slashing, the contracts immediately know it. We can immediately intimate the service that the other services that may have depended on the same stakers, that the total economic security you're getting, it was 10 million, right now it's gone down to 3 million or whatever the thing is. And so we can intimate these other services about it. So that's number one, right? Like, because slashing happens on EigenLayer and all services are talking to EigenLayer, we can inform them of the amount of security that they're having. And they may say it's not enough, then they can increase the reward rate or recruit additional restakers, or, the interfaces for these on the practical markets need to be worked out. Basically, is there like a pop-up on these guys saying that, hey, there's this new staking opportunity, you want to opt in, you have this percentage rate, and people opt in. Okay. But that's the basic dynamic. With native restaking, it's a little bit complicated, at least immediately. It's because right now, smart contracts which hold the withdrawal credentials cannot immediately slash from Ethereum. The validator has to trigger the withdrawal from Ethereum. The validator has to trigger the withdrawal. But there is an upgrade that people are talking about in the Ethereum community, which is smart contract triggered withdrawals. Once that is up, which won't be part of Shanghai, but eventually, once that is up, that basically enables smart contracts to also do the same thing. You can just withdraw from Ethereum instantly or trigger the withdrawal instantly. So that's the dynamics. What happens to the slashed funds? Initially, V1, we're going with a simple design. It's just frozen, nobody can touch it, whatever, something simple. But eventually, you can create insurance bonds against slashing. So if, you're a service and you have if you want so there are two aspects of security you're getting from EigenLayer. One is shared security. Let's imagine a simple world where every restaker opts into every service. Okay. Let's say there's $20 billion of restaking and everybody's opted into every service. But you are running a particular bridge and you're this is already interesting and useful for many applications, even without specific insurance, because you're saying, oh, I'm running a bridge or whatever. To attack my bridge, you cannot just attack the bridge. You have to attack a $20 billion of security, right? And of course, because there's $20 billion, and if you attack this, and because you're restaked on all these services, you could attack all of these protocols. But larger and larger attacks become more and more difficult to do, right? If you have $20 billion, how do you exit with $20 billion? Are there exchanges? Are there liquidity? Are you going to be caught in the real world? There's just so many problems that make it, there's a hardening of security at certain scale. And so that is already a very powerful thing in aggregated security. Okay, but this is the model that we would launch with. But eventually we have this idea of creating insurance bonds against slashing. So what you could say is there is $20 billion worth of slashing available if something goes wrong. And, on my Oracle, I want to take an insurance for $1 billion of slashing. So whatever happens, if my service goes bad, I will get $1 billion worth of slashed amount sent to my contracts. Why would you do it? You would do it because, people are transacting on your Oracle. If your Oracle, or bridge has wrong state, then essentially you would lose customer funds. And essentially you can pass on this insurance back to your customers as a bridge creator and say that, yeah, I have $1 billion of insurance, and an attack takes at least half a day to be detected or 1 day to be detected. So I'd say that I don't transact more than $1 billion in a half day or 1 day period. And what that now does is I can guarantee my consumer funds are all intact, because anybody who lost their funds due to wrong Oracle, wrong bridge inputs can now be compensated via the slashing that the insurance return that you're getting from EigenLayer. So we're thinking through these markets. It's early stages, but I'm very fascinated with this idea of unconditional security. The idea being as far as the bridge's viewpoint, it is getting unconditional security. It is either getting security or it is getting the insurance fund. And if it makes sure to transact less than the amount that it is insured, then basically they, from their viewpoint, they don't need to worry about it. And I think this is a system that is not available on Ethereum or any blockchain today. Applications cannot take insurance against slashing, but I think this would be a very, very powerful primitive. We're working through all the details for it. Hopefully we'll write up some white paper on this, even for Ethereum or core protocols, but also for protocols built on top like EigenLayer to leverage something like this.
Yeah, that's really interesting. I hadn't delved deeply into the insurance slashing that you guys are also going to be able to propose with this. So that's really cool. Something else that I've been thinking about and would love to ask you is just if one of these new chains or dApps spins something up and utilizes Ethereum Trust, is there still an incentive for them to have a token? Can their native token be worked into this kind of relationship as well?
Yeah, this is a great question. And I think, what we realized is the answer to this question matters a lot. And once we had a good answer to this question, people were interested in putting on EigenLayer. So let me explain the several types of business models one can build on EigenLayer. Okay, the first business model is what I would call the least crypto native. But the simplest model is you create a new service and you say, hey, I'm creating this new wallet address, right? And you say that so let's say it's a storage protocol. Whenever people pay like $1 for storage, I as a creator of this protocol get 30% sent to my wallet address, right? Like that's it. Like I create a protocol, I take a 30% cut, remaining 70% goes to stakers. I create this economics and I kind of convince the stakers that this is worthwhile because of whatever economic gain versus risk that they're taking, and enough stakers opt in. Now I have a running service, and all I needed to do was create the service, come to the EigenLayer marketplace, convince some stakers to opt in, and then like I turn on and I have my wallet, which keeps on collecting fees. The analog of this is basically the SaaS model in in the cloud world, right? You have these clouds and then you create this software as a service model, throw the software out there, add a payment rail to it. And like whenever people are touching that service, they're paying like a little bit to your service. And as long as you can collect a little bit more than what the cost of running it is, and you just scale that service out, you kind of can make a massive business out of it. So we can and do expect people will be building services like this on EigenLayer. They just create a company and the company holds a wallet and the wallet basically collects a fraction of the fee and remaining goes to the stakers. The company doesn't have to worry anything about decentralization. They are not decentralized. They don't need a token to be decentralized. They don't need any of these things. Simplest model on EigenLayer. But it's the least crypto native. Okay, what else could you do? The problem that you face with just this business model is how do you bootstrap your platform? Like on day one, your platform doesn't have enough fees. It doesn't have enough fees to secure itself, of course, but it also doesn't have enough fees even to pay rent to security, right? What EigenLayer has done is to transform buying security to renting security to actually really what EigenLayer does is renting shared security. So you can think of buying security, the analog is like buying cars, right? Renting security, the analog is like Uber, right? Like renting shared security, the analog is like Uber pool, right? Like it's a shared ride, right? So that's really what EigenLayer is basically just like Uber pool. And so, but still you don't have money to like pay for the Uber pool. Now what do you do, right? Like what you could do is you could say that, hey, I'm creating this new token ecosystem and a fraction of the fees or all the fees basically goes to the token holders. And instead of incentivizing the initial stakers just by the actual fees, you can incentivize them by the new token that you're creating. And this is up to like each of the project to understand like what the structure of this token is, what the economics is, what the regulatory compliance is, and all of these things. That's up to these projects to figure out. But it is an innovation sphere that we have seen massively inside the crypto ecosystem, that people can use these tokens to incentivize people to align behaviors over different timescales correctly. And so you could do this. But then you can go even one more step on EigenLayer and say that, yeah, I'm not only renting Ethereum security, but I'm also like having my own security in addition, right? Like it's like saying that you have E3 staking and you get some security from it, but you also have my own token staking and you get security from it. And like both of the communities are like committees have to agree on a decision for some Oracle input or bridge input to be valid. So you can have those kinds of economics where we call this dual staking. So the simplest one, just running a wallet and running a company. This may be attractive for huge companies like Meta and Reddit and Instagram or whatever to say, hey, I'm running this new consumer service. I want decentralization. I want people to have native property rights, but I don't want to myself be decentralized. I'm running a company here, right? Like, and that is a use case that is possible on EigenLayer. To the other extreme where like you have your own token, you're paying in your own token, you're staking in your own token, but you're still renting an aspect of security from Ethereum. All of this is possible.
That comparison you made earlier, by the way, to Uber Pool, you are going to make some very young investor in a Patagonia vest in the middle of a San Francisco coffee shop, very happy one day when they listen to this. So speaking of the need for tokens, do you expect EigenLayer to have a token? I'm actually surprised. This is one thing I wasn't able to dig up. Are we to expect a token for EigenLayer?
We are in the initial phases of thinking through the economics and design of a platform like this. But the core aspect of EigenLayer is we are taking this Ethereum security and supplying it to anybody who wants to consume it. So you can think of us as somewhat like Uniswap. The idea that the security providers are like liquidity providers on Uniswap. Instead of the traders, you have the security services who are consuming the service, right? So it's a two-sided market. So, there are various ways in which you could create like an economy that of something like Uniswap. So that's roughly how we're thinking about it. When we will have a token, whether we will have a token, all of these need to be decided.
Then just a quick follow-up to that. Where, I think you kind of alluded to it, but like, where do you define like the value accrual for EigenLayer? Or where are you taking your, I guess, cut?
Yeah, it's simple. The Uniswap model, basically, the idea is that there is a fraction of the fees paid to the liquidity providers can be taken by the platform if the platform provides additional value relative to competing platforms. And like in Uniswap, there is liquidity. In EigenLayer, there is more staking. The more the staking that accrues to EigenLayer, the more the services that can be built, the more the services that can be built, the more the staking that accrues. So that's the two-sided market.
Yeah, it seems like there's a lot of like different points in that relationship where, there's potential for value accrual.
That's right. And, we are very open to like understanding different kinds of models. It could very well be that we build services on top of EigenLayer, and that's one example of how value accrues to us. We are very open in how this can be structured in a way that maximizes the surface area of innovation. So that is really what we want to optimize. But one thing we did find is as you start writing data to Ethereum frequently, the Ethereum gas fees can blow up rather quickly. And so we have to make sure that there is an economics where we can ensure to be able to do that correctly.
With over 60,000 subscribers and 450 integrations, Push Protocol, the leader in Web3 communications, just launched Push Group Chat. While Push Chat already enables secure and private wallet-to-wallet messaging between any wallet addresses, the new Push Group Chat allows anyone to permissionlessly create groups, share files, and collaborate with communities natively on Web3. Try it now at app.push.org.
One thing I kind of wanted to give you the opportunity to address, Sreeram, is I've seen you on a lot of podcasts, read a lot of papers, tweet threads, and is there anything like we're missing or that you'd really like to get out there about EigenLayer that maybe we haven't keyed in on, or you feel like you haven't seen people kind of connecting dots to, anything like that?
Yeah, I think, there is a whole sequence of applications one can build on EigenLayer that are quite interesting, but just taking, let's say, the MEV landscape and understanding what set of solutions can be built on EigenLayer, I think there is a kind of very rich tapestry of solutions there. For example, if you're a block producer, so what's happening today is, in Ethereum, if you're a block producer, the way in which you order transactions is unconstrained by slashing. You can order transactions in whichever way, like it's your degree of freedom, it's your subjectivity. And right now, for example, there is the MEV boost market on which you can kind of like auction off your rights to sell the block. But you can create, and the way the whole basically Flashbots designed the MEV boost market is tailored around the Ethereum slashing conditions. And what it does is it says, hey, block producer, sign off on the header of the block before seeing the block. You sign off on the header. And because you're signing off on the header of the block, you have no degree of freedom other than to actually then just submit that as your block. Because if you try to send another header, then you would basically get slashed. Because if you sign two competing headers in Ethereum, it gets slashed. So the whole of the MEV boost architecture is designed around this one constraint, which is there's only one fundamental slashing condition on Ethereum, which is double signing block headers. So what this does is remove any degree of agency from the block producer. Block producer, is just signing off blindly on some block. There's no agency. I cannot say I like to include this transaction or whatever after that, right? Even if they've sold a portion of the block, they could still retain the ability to add some transactions at the end, and they don't have this. But this alludes to the more fundamental thing, which is as a degree of freedom as a block producer on Ethereum is very, very, there is no constraint. Because there's a lack of constraint, there is a lack of credible commitments. Because there's a lack of credible commitments, nobody's going to trust you. So suppose you say, I'll be nice, I'll include your MEV block in the middle, in the beginning, but then I'll do whatever at the end. Why would people trust you? You're a pseudonymous person. So the pseudonyms cut both ways. There's no human trust. There is only like algorithmic trust. So what EigenLayer does is restore algorithmic trust and say that you can make a credible commitment that you will include something at the beginning of the block. You can say that I'm selling the first 1/3 of the block space to DeFi Dad and the next 1/3 of the block space to Adam, and then I keep the 1/3 of the block space to myself. You can say whenever there is a liquidation, whenever there is an arbitrage between, like, let's say atomic arbitrage between Uniswap and SushiSwap, I have to close the arb and spread the value to the Uni and Sushi token holders. This is a requirement if I'm a restaker opted into this particular arbing service. There may be a liquidation, and I say that you can start creating event-triggered actions that the block proposer has to take. Looking at the current set of state, this liquidation has to be triggered, this CryptoKitty has to be birthed, this event has to be triggered, and I opt into it, I have to do it. If I don't do it, it's attributable. I know, it's me. I didn't do it, I'll get slashed. So, and what these kind of things do is they massively increase the DeFi efficiencies. Okay, let me explain why it is. For example, how is the over-collateralization factor determined, right? It is in the time to liquidation, what is the market volatility, right? And the time to liquidation has to be determined based on, worst case censorship resistance assumptions, right? And you cannot say that you'll get, I'll liquidate you in 1 block or 2 blocks, right? That's too tight a latency. Once you have event-driven triggers like the ones that I just talked about, what you could do is you could say, you should set your event-driven trigger to refill your collateral or whatever within this period, otherwise you'll get liquidated. So you can massively reduce liquidation times. By reducing liquidation times, you kind of reduce the over-collateralization factor, making very efficient DeFi systems possible. So I think extracting and extrapolating out what infrastructure efficiencies lead to what efficiencies upstream into the protocol layer and into the application layer at the very infancy. And this is something I'm very fascinated about. What are ETH native? Recently, Vitalik wrote an article about how to use something like EigenLayer potentially for RAI as a one of the collateral types. The set of ideas for what could be built on top of native restaking is quite powerful, and we hope the community will engage closer on these topics.
With all this talk about the benefits of DeFi from EigenLayer, I'm thinking I might have to rebrand to EigenDad, but we will see. Hey, one last question for you. When do you expect EigenLayer will go live?
Hopefully middle of this year. I last time I was on a panel with, I think, Justin Drake at Dark Rat Fest, and I was some Ethereum guys there. Somebody asked me the same question. Said, we are Ethereum aligned, so we don't want to give you commitments that we cannot hold. So I'm following on that. I don't know if the Shanghai timeline is announced. Right, so we're following on that. Hopefully we'll be able to deliver by middle of this year, but no concrete commitments yet.
Yeah, that makes sense. If folks listen to this in the future, we're recording in early February 2023. So we can definitely attest good things take time in Ethereum. And part of the reason I think all of us were drawn to the principles you mentioned earlier is the hardest problems, taking that time. We have a community that is, I think, very patient, and builders who put security above all else. So Yeah, I mean, whether it's middle of the year this year or later in the year or whenever, I mean, we'll be excited for whenever that launches. Well, Sreeram, thank you so much for your time. I mean, you're very generous in speaking with us. I want to remind listeners they can go to eigenlayer.com to learn more about what you're building. They can follow you on Twitter I'll put this into the show notes, Sreeram Kannan, just his name spelled out. Is there anything else you'd like to share, though, before we go?
No, that's great. And also, there is the EigenLayer Twitter will announce more things coming up. Like we're starting a research forum on Discourse where people can communicate ideas. Any of you out there who are fascinated by this vision of maximizing the surface area of permissionless innovation, you have things you want to build, please reach out to us. You want to join our team as like a, engineer or in other roles, reach out to us. We are looking always for good people.
Thanks for tuning in, everyone. If you're a talented builder like Sreeram, please consider reaching out to our team at fourthrevolution.capital. And don't forget to subscribe to the Edge podcast. You can follow us on Twitter at edge_pod. And for links to the podcast and video interviews, check out DeFiDad.com.